In this video, we will cover our modeling workflow. In this workflow, our aim is to predict whether an order will have an OTIF status of 1 or 0. A 1 in this case representing that the order arrived on time and in full. To do this, we will be using a random forest classification model. We want to use a classification model instead of a regression model since we are predicting a binary variable instead of a continuous variable as we have in other use cases. While the overall flow is the same, instead we'll be using a classification model, and our normal regression evaluator node will be replaced with a multi-class classification evaluator. This will give us the statistics relevant to a classification model instead of a regression model. In addition to these metrics, we will also aim to then group the data by either the customer or the OTIF status, and to then produce visualizations that will help us better understand our results and our model performance. We can also use these same visualizations in a future video when we build a report. Now let's take a look at the execution of this workflow. We'll first start with our multi-class classification evaluator. This gives us the confusion matrix. This shows us the count of each of the different options presented by either our target or our predicted label. When the target and predicted label have the same value in a confusion matrix, this means that the model predicted correctly, in this case 160 times. The two values in between, where the target and the predicted label are different, are essentially our error, these 36 values in between. We can also see this in text format, and we can look at our F1 and our accuracy. In this case, our accuracy was 84%, meaning that we correctly identified or predicted the OTIF status 84% of the time. Next, we have our row values. This is a simple printout of the values contained within our dataset, now with the predictions from our model added on. Now we are getting into the visualizations that we created at the bottom of our workflow. Here we have the actual values of the percentage from each customer, Procter & Gamble and Unilever. We can see that Unilever delivered more late deliveries than Procter & Gamble. Here we have the customer-wise actual values for on-time delivery rather than late delivery. This is essentially the inverse of the graph that we saw earlier. That is why Procter & Gamble in this case takes up a larger percentage of our pie. Next we have the row values with the percentage added. This is basically an enhanced version of our confusion matrix. In this case, we have added not only the percentage, but we have also split up the orders by each of the different customers. Now we have our predicted values. In comparison to the pie charts shown earlier, this contains not the actual values for late and on-time deliveries, but the predicted values. Later we will compare these two pie charts to see how our model stacked up against the actual values. Here we can see that our Procter & Gamble on-time deliveries made up for 60% of our on-time orders. This is a larger percentage than the 55% that was shown in our actual values. This means that our model predicted that Procter & Gamble should have had more on-time deliveries than they did. This can be an important takeaway and may be something to look into in the future. Thank you for listening.